Okay, so there are 5 different general categories of EC2 instances. There are general purpose, there are compute optimized, memory optimized, GPU, which basically they include a GPU on board, graphics processing unit, and they also have storage optimized. Okay, so the first one we want to talk about are the cheapest ones. These are the least expensive, definitely good for development environments and stuff like that. They're known as Ts. Now, every instance type is going to have a letter plus a number. So T is telling us the type of instance, and 2 is telling us second generation. Every instance type is going to go from 1 to 2 to 3 to 4. As Intel comes out with new technologies, they get incorporated into the AWS instances. So T2 is a later generation than T1, for example, right? Now they're very inexpensive, and matter of fact, when you have a brand new AWS account for the first year, T2 Micro is an option to use for free. Okay, so that's how cheap they are. They're even free. So they're the least expensive, and costs go up depending upon the size you pick. For all instances, the larger size you pick, the higher the hourly charge is. But hourly charges are dependent upon the type you pick plus the size. Now, the reason why these are the cheapest of all that we're going to talk about is because of the CPU. Now, you'll see on my table down below that the different size instances for T2 have a different number of virtual CPUs attached to them, either 1 or 2. The thing is, though, that they're not 100% dedicated all the time. It's a burstable access CPU. So in other words, I don't get to use 100% of the CPU capacity full time. I only can burst up to 100% when I need to. And this is also a credit system. So you accumulate CPU credits when you're not using the full CPU, and then when you need to use the CPU, you burn off the credits. Okay? So the larger your T2 instance size, the quicker you accumulate credits, so you can use more of the CPU longer, and the smaller gives you fewer credits to use. Okay, so if you need more credits for your T2s, you usually have to go to a larger size. You also can see the table, how much memory is given. Every time you go up a size, you get more memory on board. And then also you can see that this particular type does not have local instance storage. So it does not have instant store. Ts only have EBS volumes. Okay, another type of general purpose instance is called an M. Now the main difference here is that we don't deal with that whole burstable CPU thing. You get dedicated CPU capacity. Okay, so you can get in the 100% CPU as often as you want to. Now the M's have been around since generation 1, so there's M4 and M3 are still current. So there's M4s, which are Haswell processors. These are a little bit later than the previous ones, which are Sandy Bridge. So they're more powerful processors, but general purpose instances, generally, we're not looking to necessarily have the most powerful processors. Those are the compute optimized instances. So when you have a general purpose instance, you're looking at things like, websites, general databases, enterprise applications, stuff like that. Nothing that needs a lot of CPU power all the time. But at least you don't have the bursting on these M1s. Okay, so you get a good balance of compute, memory, and network. So you can see you get multiple CPUs, 2, 4, 8, 16, up to 40 CPUs. You get a lot of memory, potentially. You get SSD storage is not, SSD storage is not an option, but you do get some good dedicated EBS bandwidth. Now, let me explain what this is. Some instances have what they call dedicated EBS optimized network. Okay, so with EBS optimized, when you're writing and reading to your EBS volume, remember it has to go over a network connection. Well, with EBS optimized, these instances don't use the regular network interface. They have their own separate network connection to read and write to the EBS. So that gives them better consistent performance with EBS. Okay, so the M4s we just looked at. M3s are a little bit older. These are Ivy Bridge processors, actually. I said Sandy Bridge, I meant Ivy Bridge processors. These are a little bit older, but notice there's one big difference on the M3s. These do have local SSD storage. Okay, these do have it. And the last one, the M4, got rid of it. So if you want a general purpose instance with SSD storage, and this is a good amount for you, then that would be the one to pick. Again, same similar use case to what we saw before, but basically this one comes with local instance storage. Okay, now compute optimized. So if your application's really going to do a lot of, number crunching or processing of some type, like analytics, batch processing of data, you're probably going to need a compute optimized instance, the Cs. And this is C4. C4 also uses Haswell processors. EBS optimized does not have local instance storage, but it has something known as enhanced networking, which is great for any type of HPC environment, high performance compute clusters and things like that. So they can communicate over the network with really, really good performance and low latency. Okay, the C3s are still out there. They're a generation back, also Ivy Bridge processors, but these have local instance storage. Okay, that's their main difference. The processors are a little older, but they do come with local instance storage. Okay. Now we've got a really high performing instance, a very expensive instance. Now these other instances we talk about, they're like cents to maybe a little less than $1 an hour to run. X1s are like $7 an hour to like $15 an hour. They're really expensive, but they're super powerful. Take a look. They have either 64 CPUs or 128 CPUs on board. They can have up to 2 terabytes of RAM, right? 4 terabytes of local storage, right? And they've got a large amount of dedicated EBS bandwidth. Now, because there's so much RAM on these things, so much memory, they're good for in-memory applications like databases, right? So things like Spark, right? Presto, anything that needs to be stored in memory, right, is going to be really good. And SAP HANA, memory database, right? They would be all good use cases for a memory optimized instance. You just get a lot of RAM on these instances, plus a lot of CPU. Very high performing instance. Okay. Now a lot cheaper, but memory optimized also is R's, right? And so the R3, you can see how much memory you get looking at the memory column here. Quite a bit of memory. You get a large amount of gigabytes of memory per penny. So it's a pretty good instance when you want to have, say, like memory cache, like something like Memcached or Redis type of thing, where the NoSQL database runs in memory. Good choice for that. And again, it's good for even relational databases, because relational databases tend to perform a lot better if they can cache results in memory. Okay, and you can see ours do come with SSD storage. All right, so now there's R4, which is a later version of R3, which doesn't have SSD storage, but it uses the latest processors from Intel known as Broadwell processors, right? And these guys are a bit better performing overall. You can see they go up to 16 extra large now, which is 488 gigabytes of RAM and 64 CPUs. Okay, now we've got two that have GPU controllers. The first one is the Ps. These are sort of general purpose, but they have GPUs. Only 2 instances out there, the Ps and the Gs, which are the next one, actually have onboard GPU controllers. These are NVIDIA K80 GPUs. So they're good for modeling, scientific simulations, machine learning, genomics process, things like that, where your application could leverage the GPU processor in addition to the CPUs. And you can see, depending upon the size, how many GPUs are given to you here. No instance storage on the Ps. Okay. Then we've got the Gs, which do have instance storage, also have GPU controllers with onboard video encoders, Sandy Bridge processors, and they're good for video encoding, for example, or 3D application streaming. All right, then we've talked about these already, the storage optimized or i3s. This i3s just came out recently. This is the newer generation. Before they were i2s. This is the newer Intel processors, and they have lots of local instance storage. That's why they're called storage optimized. These are super fast SSDs. These are non-volatile memory express SSDs. Extremely fast, up to 3.3 million random IOPS. So 3.3 million input outputs per second. And you can see, depending upon the size, how much local storage you get, and it's pretty big. Okay, so you get a lot of local storage. Great for NoSQL databases that are running in clusters and, you know, replicating your data across the cluster. Hadoop, same thing. It's a cluster, replicates data up to, you know, 3 times standard for Hadoop. Any kind of cluster-based file system, this would be really good and really fast for the IOPS. Okay, the other type of storage optimized is HDD-based, right? And you can see on the slide how much you get for the different size of D2s. Again, the difference here is that you want to do more of a continual I/O instead of a random I/O. So like a data warehouse, MapReduce, right? Maybe network file systems. These are all good choices for the local instance storage, HDD-based D2 instances. Okay, now this is the newest one, right? This one just came out and people were kind of shocked. It's called F1. Okay, now F1 is field programmable gate arrays. Now with these F1 instances, you can create your own hardware acceleration for different applications. You can build your own hardware acceleration for your applications with these programmable gate arrays. Okay, this is a very advanced technology. And so they're good for genomics research, video processing, network file systems, but with your own programmable hardware acceleration. Again, they are much more expensive. They're more like on the lines of the X1s in terms of the cost for them, but they do give you really, really impressive capabilities.